Okay, chain rule, day number 2. Today we're going to expand our ability to use the chain rule. We've just started learning about it last class, and today we're going to use it to differentiate functions that are defined numerically rather than with a formula, right? But where you just have a few values of the function. And to be able to take the derivative of the composition of more than 2 functions. Okay. So we're also going to learn how dogs do calculus. Yeah, it's pretty exciting. Okay, so remember the chain rule, a method for finding the derivative of a composition of functions. If you want to take the derivative of f of g of x, right? G we called the inside function yesterday, the one that's embedded, and f we call the outside function. So we take the derivative of the outside function, evaluated at the inside function, times the derivative of the inside function. That was the chain rule. That is, if you want to take d dx of f of some stuff, you take f prime of the stuff times the derivative of the stuff. So we've got 2 functions here, f and g. I do not have formulas for f and g. I just have a bunch of values for f and g and f prime and g prime. So I want to find the equation of the tangent line to h of x, and h of x is some mishmash of things with f's and g's and squares. The equation of the tangent line at x equals 1. So before I even start messing with the ugliness that is h of x, what do you need to find the equation of the tangent line?
Derivative.
You need the derivative. What does that give us? The slope of the line tangent to the curve at the point. So I need the derivative at x equals 1, right? That is, I need h prime of 1, because that is the slope of the line. Right? I need h prime of 1. That's my slope. What else do I need to find the equation of a line? If I have the slope, I need b, and I need a point to get b. So I need a point on that line, so how would I find that? Plug 1 into h. So I need another point, and that point would be 1 comma h of 1, right? Because this is the point of tangency. It's on both the curve h and the tangent line. So I can use it as a point that's on the line. So I need the slope, and I've got a point. So let's start with the derivative. So if I need h prime of 1, I'm going to start by trying to find h prime of x. Once I have h prime of x, then I'll plug the 1 in. Okay, so here's my h of x. 4 times f of the quantity x squared plus g of x quantity squared minus f of g of x. So the things that are separated by pluses and minus, we can just take each of those derivatives separately, right? You can take sums and differences are intuitive. So let's just start by working on this 4 times f of x squared. So 4 is a coefficient, so it can just come along, right? 4 times, and then I start taking the derivative of f of x squared. So that's a composition. What's my outside function for f of x squared? F, and my inside function is x squared. Okay, so if I'm going to follow the chain rule, I have to take the derivative of the outside function evaluated at the inside function. So I'd have f prime of x squared times the derivative of the inside function, which is 2x. Yeah, the derivative of x squared is 2x. All right, so that is my first term using the chain rule, plus. Now I have g of x quantity squared. Now, what is my outside function? X squared. The squared is the outside. G of x is embedded, right? G of x is the inside function. It's the thing getting squared. Okay, so g of x is the inside function. X squared is the outside function. Think of this as some stuff squared, right? So I'm going to apply the power rule to the stuff. So I take that 2, bring it down, copy the g of x, reduce the exponent by 1, right? And then I still have to multiply by the derivative of the stuff. How do I write down the derivative of g of x? G prime of x. Minus a composition of f of g of x. What's my inside function for f of g of x? G of x. So that's my inside function. My outside function is f. So I take the derivative of the outside function, f prime of g of x. So f prime evaluated at the inside function times the derivative of the inside function, so times g prime of x. So that's my chain rule. Well, I'm trying to find the equation of a tangent line, right? This is just, I've just found the derivative, h prime of x. So now I have to plug in a 1 to get the slope of my tangent line. So h prime of 1. So when I put a 1 in here and square it, I get 1. So this is 4 times f prime of 1 squared times 2 times 1, 2 times g of 1 times g prime of 1 minus f prime of g of 1 times g prime of 1. So I just put in a 1 for every x there, and now I'm going to try to evaluate this thing. Okay, so f prime of 1 they gave me. It's -2. So now I'm going up to this list of values that they told me. F prime of 1 is -2. So I've got 4 times -2 times 2 plus 2 times g of 1. What is g of 1? 2. And g prime of 1, -6. Right, so I just did the g prime of 1. And then minus f prime of g of 1. What is g of 1? 2. So instead of g of 1 there, that's 2. Right? And f prime of 2 is 10 times g prime of 1, which is -6. All right, so I've got -16 minus 24 plus 60. 20. So that is the slope of the tangent line that I'm looking for. But I want the actual equation of the tangent line. Okay, so I've got my slope. Right, my slope is 20. Figured that out. Now I need a point. In order to find the equation of a line, I need a point and the slope. Got the slope. Here's my point, 1 comma h of 1. So h of 1 means plug a 1 into the original function, h. So I have 4 times f of 1 squared plus g of 1 squared minus f of g of 1. Okay, so f of 1 is 4. 4 times 4 plus g of 1 is 2. 2 squared minus f of g of 1. And g of 1 is 2. And f of 2 is 7. So I get 16 plus 4 is 20 minus 7 is 13. So my point is 1 comma 13. So I've got a slope of 20 and a point 1 comma 13. I can now write the equation of a line. I like the point slope formula. just because you don't have to do any more calculation. You just plug in the point and your slope. So this comes out to y minus the y of your point, 13, is equal to your slope times x minus the x from your point, 1. And if you really want mx plus b, you can distribute your 20 and add your 13 to the other side. Y equals 20x minus 20 plus 13 is minus 7. Either form of the line is fine. So you'll have some homework problems like this tonight where you're going to be applying the chain rule, but you don't have actual formulas. You're just going to have some values of f and g. Okay, so also, the other thing we're going to talk about today is when we have to apply the chain rule repeatedly. So sometimes in the process of evaluating the derivative of the stuff, the derivative of the inside function, sometimes you have to use the chain rule again when you're doing that. So for example, let's say I want to find the derivative of e to the sine of 2x minus 4 cubed. This is a composition of 4 functions or something, right? My innermost function is the 2x minus 4. It's being cubed. Then I'm taking the sine of it. Then I'm raising e to all of that. So this is a composition of like 4 functions. So if I want to find y prime, just think of this as e to some stuff, right? E to some stuff. What's the derivative of e to some stuff? Do you remember from yesterday? E to some stuff. So y prime is going to be e to all this stuff. Sure.
What is that in real life? What would a function like this?
Oh, this particular one, I don't know, but
I understand we do things like examples.
yeah.
Will we ever see this?
You'll definitely see the chain rule. Having to take a derivative of 4, maybe, maybe not. I don't know. Okay, so I've got e to some stuff, right? The derivative of e to some stuff is e to some stuff. Then I still have to multiply by the derivative of the stuff, right? And my stuff, oops. Okay, the stuff is the sine of 2x minus 4 cubed. So that's what the chain rule says. Derivative of the outside function, just apply the standard derivative rule, then multiply by the derivative of the stuff. But now if I wanted to take the derivative of this stuff, that's also a composition. So when I'm taking that derivative, I'm going to have to apply the chain rule. Okay, so as I write this out, I'm going to recopy everything so that we don't get lost in our work. I understand if you don't write every single step and every single line when you're doing your own work. But just so I don't lose anybody, I'm copying down the part of the derivative that I already did. Now I have to work on how to take the derivative of the sine of 2x minus 4 cubed. Well, what's the derivative of the sine of some stuff? Cosine of that stuff. Yep. So this is going to be the cosine of 2x minus 4 cubed. Right? The derivative of the sine of some stuff is the cosine of that stuff, but then I still have to multiply by the derivative of the stuff. This is why it's called the chain rule. Yep. Chains down. Okay, so now I've done 2 pieces of the derivative. I'm just going to copy them down, and then I'll work on doing the piece of the derivative that I haven't gotten to yet. So copy the parts that are done. Okay, so now if I wanted to take the derivative of 2x minus 4 cubed, how would I do that?
The outside of the derivative of the outside, evaluated at the inside function times the derivative.
Great. Okay, so what's my outside function? X cubed. So I'm going to take the derivative of the outside, which means bring the 3 down. This is some stuff cubed, right? So I'm going to take the derivative, standard derivative rule, bring my 3 down, copy my 2x minus 4, and squared. So I've done my power rule on the stuff, but then I still have to multiply by the derivative of the inside stuff, dx of 2x minus 4. So yeah, I could just write times 2. But I'm going to write it all out so that people have this at least once every step written down. So the derivative of 2x minus 4 is 2. So I'll do the 3 times the 2, so I get 6 times 2x minus 4 squared. No? Good. Good. I like to hear that. Okay, so that's it for lecture. You have some group activities where you will practice using the chain rule on multiple functions and then doing some stuff numerically.